This talk is going to just be on using Python at NERSC. Can we get a few reactions of who all will be, using Python in some way, shape, or form to your knowledge on any, whether it's data analysis or maybe some of your calculations or simulations are going to be. Okay, we got a few thumbs up. Cool. Good deal. And so, again, my name is Charles Lively. I'm a science engagement engineer, again, with Lippy. These slides were taking from original material from another NERSC staff member, Daniel Margala, who is in our programming environments and modeling group. And so at NERSC, we have various groups that help keep the machine or keeping the ship running. We're in user engagement group. We have several other groups that are invaluable to making sure that we have access and control for our systems as well. So today we're going to just talk a little bit about using Python at NERSC and just a little bit why it's a little bit different from maybe if you use it on your personal laptop or on other systems, and just some general best practices that we recommend as well. So using Python at NERSC. So NERSC has available various different Python modules that you can make use of. And so to get started with Python, you would just do a module load Python, and it will automatically go to the default. The default module that gets loaded is Python 3.11. We also have 3.12 and 3.13 available, but 3.11 is the default that you would get once you do your module load Python. And so once you are there, it's very easy to, this is just a simple, hello world or hello, welcome to new user training to using Python once you're on Perlmutter. And we'll go into more detail on our hands-on interactive tomorrow as well. So this is just kind of giving you an overview of using Python on Perlmutter. So Conda is a package manager that we use for building custom environments. In order to make use of Conda, we have it available as a module. And so Conda is great for creating various environments that you can use without having to have any dependency issues between different libraries and whatnot that you would need to use. So this is great for if you're, working with various different applications or simulations and you need to have very specific environments that you need to make use of. And so Conda makes it easy for installing and resolving those package dependencies. And so once you do module load Conda, you don't have to do a Conda init, which is, different behavior from if you're used to using mini Conda or Conda on your own systems. So that's just analogous to our implementation of it on Perlmutter for you to make use of. And so once you've loaded Python, you can see all of the various Conda packages that are available for you to make use of within that specific module. So, here's just a truncation of some of the different Python Conda packages that are available for you to access once you have loaded that module. And that just makes it easy for you to conveniently pull different packages to develop your environment. And so okay, what are some different options for using Conda at NERSC? So once you have loaded Conda, and let's say you want to create your own custom environment, you just use the Conda create command. Then what you're going to do is you will name your environment. In this case is myenv. And then you will list all of the different packages like we listed previously, that was shown previously that you want to use. So that includes Python, NumPy, and SciPy in this. And then once we have that created, we can just do our Conda activate and activate that new environment. And then we are now in our safe sandbox to make use of it. So you can also use Python from different containers. So let's say a newer version of Python comes out, NERSC has not adopted it, but you want to make use of it, or NERSC has not loaded it as a module just yet. Making use of containers is another way to allow for flexibility and control of your environment as well on Perlmutter. Okay, now there are different options for using Python at NERSC. If you do a typical which Python, this is going to point you to the default system loaded Python, but that is not the Python that you want to make use of. You want to make sure that you do the module load Python. This is the system default, and it's not necessarily configured optimally to make use of all of the different resources and the dependencies that Perlmutter requires for executing HPC workloads efficiently. So, you want to be aware and make sure that, if you do the which Python without having done a module load, it's going to point you to the Python that you're primarily not interested in using. I'll just say, probably more than likely so. It's not the one that you want. So always make sure that you use Python within a Conda environment or from a container as well. And that just ensures, that it's performative and compatible to the science that you need to do. All right. So package installation tips, and Lippy kind of touched on this in the data talk a little bit. We have a few different, tips and advice for working with our Conda environment. So you want to make sure that you understand that Python packages are installed and should mostly all work at NERSC, and they can be installed from Conda from different channels. And in many cases, you can mix some of the different channels that you want to make use of. But sometimes this can lead to version conflicts. So you want to make sure that you check using Conda list. For example, CUDA toolkit can be used as a module versus a Conda package as well. So some of these are already available to you by default within your Conda as well. So you want to keep in mind that the CUDA toolkit by default in the Conda environment might conflict with the CUDA toolkit module that you might have loaded by default. So some things, dependencies and things like that we want our users to keep in mind. And this is another point. A lot of times when we get a user ticket, we'll commonly ask them to send us a copy of your current environment, like a screenshot of ENV, so we can see what packages and modules you have loaded as well. Another thing that you want to make sure to understand on working on Perlmutter, and tomorrow our colleague Justin Cook from the Programming Environments and Modeling Group will go into more detail about our programming environment and different compilers we have available. But a lot of our Python packages are compiled in compiler wrappers, and those wrappers are basically there to enable the compiler to be more performative for HPC workloads. So, a lot of different compilers, whether it's C, C++, or Fortran, these are made use of with different system provided compiler wrappers instead of the traditional GCC or G-Fortran. So this allows for you to ensure that you have the right compiler that you're using that matches to the appropriate, if you're going to use an MPI or appropriate Cray library as well. So an example that we can have is like making use of MPI 4Pi. So MPI 4Pi is a Python interface that provides MPI implementation. And so on Perlmutter, if you do module load Python, that is automatically going to make it available MPI 4Pi for you to use. And that has CUDA support with Cray impitch. And again, if you want to install it within your custom environment, you can use this simple example gives you an overview. You'll want to do a module load the specific environment, and then whatever packages as well. So programming environment, GNU, CUDA toolkit, various other Cray and modules that are loaded. Then you'll create that environment. And in this case, we're naming it MPI4Pi-GPU, providing the Python package that we want to use. And then we have our activation for it as well. And then we're able to do an installation for other different directives as well. But one thing you want to make sure that you're aware of is that in order to use the CUDA-aware MPI4Pi, you must have the CUDA toolkit loaded. And that is even if your code doesn't make use of the GPUs. And again, that goes back to how we have specific wrappers and packages that are utilized to make sure that you're getting the optimal libraries for each of the compilers and wrappers that you need to make use of. Okay. Did we have any questions so far? Good to go? Okay. Now, a thing about pip is that you want to be aware of is that you want to use it with caution. And, this goes into a lot about your data hierarchy and data optimization, because pip will install packages into a local cache, and that can create a lot of conflicts and other unexpected behavior. So, on Perlmutter, the system is going to install it. If the system install directory isn't writable, it'll automatically fall back to your user install, and most users do not notice that. And so a lot of our tickets, we do get, a lot of users don't realize that they've created all of these different Conda environments and have, literally exhausted their home directory because of it. So that can be a little bit confusing. So you want to make sure that you are actually using specific directives. You want to make sure if you're using pip, install it inside of your Conda environment and not outside. And, these specific flags are what you can use as well. So, and you'll notice that this is kind of what we had in our previous slide for the MPI4Pi as well. So that's just another caveat that you want to make sure that you keep in mind, that having the appropriate flags to make sure you're installing and creating your Conda environments appropriately as well. Okay. And so running Python at scale at NERSC is pretty simple to do. We have, our various modules and imports that you're able to make use of for our shared file systems. So whenever you're running Python in parallel, what we always recommend is, you want to make sure that you use a container to cut back again on, any load on the file system. You want to make sure you set appropriate prefix options for your environment with Conda create. So you'll want to, force it for your project into a specific directory. And that allows for other people on your project to have access to it. And again, you want to avoid installing in home as well as in CFS as well, because it's not performative. Right. And so some other common parallel Python pitfalls that users can unknowingly fall victim to is that, with Python and you're doing nested parallelism, you can have oversubscription of resources. And so what we mean by oversubscription is that you are allocating or requesting more resources than are physically available for you to use. And this can be a little bit more complicated when you're working on shared nodes, in nodes where you don't have complete access, and you maybe by default request more resources than you have available. And so whenever you're working with Python in parallel, you want to make sure, and you're using multiple processes, just make sure that the number of processes per node times the number of OpenMP threads doesn't exceed that number of physical CPU cores available per node, and as well as available for what you requested. Um, a few things to keep in mind. There are, system methods like, CPU count, and these return these are set to return a default number of workers, but it doesn't account for CPU binding. So relying solely on that can erroneously have users oversubscribe the number of cores that they need that are available to them. If you need to respect, appropriate CPU binding, make sure you use the process CPU count method instead, and that's available on, the newer Python version. So important to keep in mind with any nested parallel applications that you want to make sure that you specify the number of workers that you're going to use, and do not just rely upon a default. Make sure you're aware and understand the resources you're allocating, and what you're making use of, so you don't get any errors or you're wasting your allocation as well. All right. So using Python at NERSC at a high level, again, make sure you make use of Conda environments or containers. That allows for you to customize your Python environment into a sandbox. Make use of the global common file system or containers for a more performative experience. Make use of appropriate compiler wrappers as well. No need to use conda init. And please be sure to be careful with using pip for installation, and watch out for, oversubscription of resources as well. That is an overall summary, but some other things to keep in mind for a last little bit is that, can we get a show of reaction or show of hands if anyone here will currently is going to be working with Python, but you don't know if you'll be using CPUs or GPUs, or you'll be maybe working the transition from maybe a CPU only implementation to a GPU or version or mixed version as well. Do we have anyone that knows if they're going to be needing to try and incorporate Python running on a GPU versus what they currently work on? And I only ask that because, it's important to understand that a lot of the Python libraries don't utilize GPUs out of the box. And so we have different Python GPU frameworks that we kind of use as drop-in replacements. So we have, CuPy and Rapids, and these are different, libraries that support GPU computing for us in place of our typical NumPy and SciPy. Because working with the GPU, again, it's different dependencies and libraries that need to make use of. So we have different libraries to support it. So such as PyTorch, TensorFlow, JAX, and you can write your own, GPU kernels using NumPy, CUDA-Python as well. And then we have other available different distributed models as well. So DAS, cuNumeric as well. And then we also have adopted CUDA array interfaces for being able to pass array-like objects for storage and GPU memory between different libraries. So it can be a little bit more complicated, the different nuances and intricacies that might be required to maybe migrate if you have a CPU Python application to making use of GPUs as well. So we just want users to, understand the differences and be aware of, some of the nuances that might be required for porting your code to a GPU if it's not already GPU portable. With the CUDA toolkit dependencies, you want to make sure that you understand, CuPy, the Conda Forge package is going to pull that CUDA toolkit dependency into your environment. So you'll want to just make sure that you're using that effectively as well. So here with that, we can, in the line below, we install it. And then from this, we'll pull it from that CUDA toolkit dependency into our environment as well. Now, another thing to consider is the workload, or how you can effectively make use of a GPU for your current application. So if you're working with the application or any kernels or modules that are doing computation using large arrays, matrices, or images, and the data can be partitioned easily to fit within the memory requirements of a GPU, then that means that it would probably, and IO is not like a significant bottleneck to, a calculation or a specific kernel within your application, then GPUs ideally would be a good fit for you, because, you want to make use of a GPU for applications with a low latency and a high throughput. So if it's able to fit easily into the GPU core memory, then it's likely going to be you're likely to get a performance improvement based off of that. And so there are different, scalability studies and things that you can do to kind of determine if that is possible as well. And this just is meant to be as a kind of like a cautionary tale that not all workloads can, be migrated to different, architectures and different systems. So that's another thing that we want all of our users to be aware of and to keep in mind. So let's see. So wrapping up, again, some best practices. You want to make sure you utilize Conda and check out the Python and NERSC docs that we have available. As Lippy mentioned earlier, our documentation is really extensive. And as Rebecca mentioned, a lot of supercomputing facilities around the world actually make use and refer to our documentation. So we say all of that to say that it's very detailed and extensive. But if you are ever confused, we encourage you to submit a ticket for assistance. As Rebecca mentioned earlier, we're a user facility, and it's our goal to help our users to get the most of your allocation. We know a lot of our users, especially if you are a student, you might only have access to Perlmutter for a year or maybe 2 years at the most. So we encourage users to submit tickets proactively, detailed, so we can help you make progress appropriately. Because as a user facility, if we don't help our users, then we don't have a job. So we encourage you to reach out for help and for assistance and any guidance that you may have as well. And, it's very easy to make use of our documentation. So please make use of it. Easy to search for things. And again, welcome to NERSC. And hopefully we can help you make productive use of our systems. All right. That is everything for me.